What's the first step to securing your app? That's right, it's conducting threat modeling. This video will guide you through a comprehensive threat modeling exercise for an app. We'll be using cybersecurity.com as our tool of choice. Stay tuned, and by the end of this video, you will be equipped to do the same for your app. As discussed in previous videos, threat modeling is based on the circular process, and we'll go through them step by step. Before we crack on, let's just remind ourselves what the various process steps comprise. In the identify step, we'll identify and describe the asset, enter an ample description of the application serving the asset, and also the normal or expected usage of the app. When you're done, you can run a simulated attack to identify all conceivable design weaknesses based on your description. The assess step commences with an analysis of the result from the simulated attack, followed by an assessment of what to do with the various findings. The simulation will also identify the key threat actors most likely to attack you, their means, and what the most plausible impact would be should they succeed. In the control step is where you identify how to fix your vulnerabilities and assess the effectiveness of your controls. When done, deploy the control and mark it as fixed. The monitor step is where you monitor your app for new vulnerabilities and at the same time oversee that the existing controls do what they expect them to do. If a new vulnerability is discovered, a new cycle of the process is sparked. So let's get cracking, shall we? Okay, so we're in. In the identification phase, we need to provide some basic configuration, and we do that by first describing the asset, the key data, and some characteristics of the market you're serving. Then we need to describe the application or system that serves the data, and at last the various users who interact with the app in any capacity. So we start off by configuring the asset. Let's imagine that you're building a killer app for weight loss. We're going to call it Best Health. Notice the red label saying Best. That would be the logo in the threat model as we shall see a bit later. Enter a solution description and also the nature of the information that you will capture and process. Select the industry sector that best matches the one you are operating in, and last, select primary impact if abuse. Next up is to configure the application, which is divided between the front end and back end. To configure an area, hit the cogwheel button and select the desired item from the select list. Do this for all relevant areas so it matches your real-life setup. To monitor your application components, you need to provide a version of the component. Describing your application configuration is an important part which will form the basis for attack simulation. The last step in configuration is to create a normal or expected usage profile. To configure each user type, click on the table row, give it a short description and enter your user volume for this type. Data input and output refers to what information classes the user type can submit into the app and what can be viewed in the app, be it the front end or at the back end, or both. Also, select types of devices in use in your operating system. Now that the configuration is done, we'll be presented with the threat and defense model. The diagram in the middle, coined riskgram, illustrates our configured app as well as the potential attack vectors. And now we're ready for the last step in the identification phase, namely to run a simulated attack. Lean back and have fun. So no less than 103 potential design weaknesses. Notice the key threat actors that are most prone to attack you since you're dealing with personal identifiable health data. The possible design weaknesses also creates a huge attack vector, and in this case we also notice that some of these weaknesses creates what we call a trust boundary violation. We'll talk more about these particular design weaknesses in a later video. Consider the findings as a checklist where you assess each one of them and determine what to do. You can get further information by expanding your own. You should be meticulous about analyzing each plausible design weakness. This is one of the greatest learning points in developing secure applications. When you're done assessing a category, the number label turns green. When you have assessed all categories, you save your model to get ready for the next simulation step, when the identified threat actors pull out their vast arsenal of methods to attack the verified weaknesses and other vulnerabilities related to the expected usage. Now look at that, an additional list of vulnerabilities and thus a few more attack vectors. The attacking method that scores best are also listed. This will give you valuable input when you start working on mitigating the vulnerabilities. A control must be added for each design weakness and vulnerability identified for follow-up. Even if a vulnerability is marked as fixed, we still need to assess the effectiveness of the control. For a control to be effective in a model, it must be evaluated and confirmed as fixed. Consider this vulnerability. After you identify the proper solution, enter a short description. Then select the nature of the control. Is it technical or administrative? Technical refers to some technical measures, such as code amendments, component upgrade or similar. Administrative refers to people or processes. A preventive control reduces the probability for misuse to occur, whereas reactive control reduces the impact should the exploitation be successful. Control effectiveness indicates how well a control is expected to work. So here we have some controls that are marked as fixed in the previous step, waiting to be assessed. Working with risk mitigation is often time-consuming, and some vulnerabilities might be considered okay to live with for some time. In such cases, you'd like to enter the monitoring phase whilst working to mitigate the identified design weaknesses and vulnerabilities. There is a concerning volume of vulnerabilities reported daily, making it essential to monitor your selected application components. Above the threat and defense model, the current risk posture summary indicates that we have 65 threats that could exploit the remaining 22 unfixed vulnerabilities. Additionally, the number of new vulnerabilities reported in the 24 hours is displayed. We need to assess if and how this will impact us. If this is the first time a vulnerability scan is run, a baseline is established, checking all relevant vulnerabilities back to the set date. To assess these potential vulnerabilities, they must be added to the model. Vulnerabilities in application components such as these need to be understood to the point where you can verify whether it must be addressed or discarded. If there are many vulnerabilities per component, you should obviously consider an upgrade. Now, we have enclosed the first threat modeling cycle and has already entered it to identify again with the newly added vulnerabilities. If you haven't already adopted the threat modeling method, I hope you see the value it gives. Getting to grips with design weaknesses and vulnerabilities is paramount in providing a secure application.